Okay, so this assumes that you already know how to get into TempleOS, like download it and everything. I'm just gonna make a file to throw it into. Lots of fucking keyboard shortcuts. So to get a sound, this will just play A key for like a specified duration. And you could do that same thing for multiple notes. There's some sort of clipping for some reason. I don't get that. But then you can send either owner values, is how he represents sound in this. And then to get that to stop, oh no. You can type it in here too. Go back here. And then if you want to send like a specific frequency, you can do freq to ONA, and like 440, we'll send 440 hertz. And cancel that out. And here it shows the whole function. Right, up, and then select it. Okay. Right there. But it kind of explains like how to do it, but it's hard to read all of that jargon. But I'm gonna explain a little bit of that real quick. First, we would declare a variable, and this is going to tell the pit timer what to set the counter at, so basically what the frequency is going to be of the sound that we're generating. And we are going to plug in some numbers, and usually the frequency is input as a float, and so you have to clamp it to an I64 value. And then the clamp puts it within a certain range. So this timer freq is defined somewhere else in the source code, and it's basically just the system timer of the pit timer. Yeah, something like that. And then we would divide that by our desired frequency, because this timer frequency is how many times the timer, like how many ticks it has in a second. But then you set the max, or this is the minimum value, and then U16 max. And now that will make sure that it doesn't go above the maximum for a 16-bit unsigned integer. And so that sets us up for success when we set the frequency of the pit timer. So how you do that is you do out U8. Basically, you're sending out a value to a port. So you're going to set the value of the port. And you do that by, this is the port that we want to go to, and this is how you would set the frequency. And it's channel 2. But we go to, and set it to period. And this would set it for bit. And then you do out U8. You can only send it 8-bit integers at a time. And since we have a 16-bit integer that we're trying to send it, we would do that. That's not how Terry does it in the source code, but that's how I prefer to do it because it's a little less wordy. Terry does it like this, but I find it a little easier to just type that. And so now we have set the frequency of the pit. And then to make it generate square waves, we would access port 43 and set its value to 36. And if you don't know, when you type in 0x, that just tells the computer that whatever follows it is going to be a hexadecimal number. And so 36 is a hexadecimal number, which would be 16 times 3. You'd have 48 plus 6, which would be 54. So, yeah, it would be 54 in decimal, I believe. My math might have been wrong. And then to turn on your PC speaker, you do this. I don't really fully understand what you're typing in here, but it turns it on. And so if we run this, it should play a sound. There we go. Mute that. And then if you want to, let's say we only want it to play for a specified duration, we would do sleep 1000, and then you want to turn the PC speaker off. And to do that, you type in something very similar. Here, actually, I'll show you a quick thing because it's not too difficult. You can just copy and paste some code. But this, also, I mean, I don't think it really matters because hex 3 and decimal 3 are like, they have the same binary value, but normally you're writing in hexadecimal values here, so I feel like it's better practice to write it that way. But this right here gets changed to $&, ampersand, I think is what it's called, and then that little curly Q thing, and then this should make it play for 1000 milliseconds because that's what the sleep timer is based on. And then it'll turn on. Perfect. So there's some basic pit timer programming. And then we're gonna explain kind of how this stuff works. So you're actually integrating very closely with like assembly language. The out U8 is like telling the hardware exactly what to do. So this would translate to assembly, right? I guess that code that I just deleted. I'll write it back out and then comment it. Okay. So that code right there, that's commented out, is the exact same as this little bit of code, which is assembly. We would set this value to 43, and then basically it's saying access port 43, and I mean hexadecimal 43, which is I think 67. I did that math a while ago. And then, oh no, that's how you end it in assembly. So this right here should do the exact same thing that it was doing before, but now you're using assembly. There you go. So there's a couple things that you can do with sound. And then on top of that, if you want, also if you close out all the windows on accident, it took me a while to figure this one out, but you can just click Control-Alt-T and it'll open up a new window for you. But I think you have to be like full screened and clicked on it or something, at least in QEMU. But then you would click here, go to Apps, Psalmody, and then this is like a really basic DAW. So right here, just go to the Run HC and click Enter on it, and then click Space on Include JIT. I think another way that you can do that is, let's do this quickly. You go to Psalmody, then Run, you can click F5 on it, and it'll just open. So if you have it opened, you can click F5. But then, yeah, this DAW is pretty easy to use. You can drag in notes, and it's like basic musical composition stuff. And then if you want to record like a little MIDI type thing, the recording doesn't quantize, or like, it just sets all your beats to a certain, like the shortest length, I believe. But then, oh, yeah. So you record that, and you can play it like this. And the tempo's way too fucking high. But we can right click on it and change the length of notes. There you go. So it's basic DAW. I'm sure you could find a tutorial by Terry explaining how to use this stuff. I don't ever use it because I prefer doing the more code-based stuff. I'm trying to figure out how to do pulse wave modulation, which is basically being able to control the on time and the off time separately, and then you can get some really cool effects doing that. Oh, I guess I'll show you real quick. If you go to so you can send a frequency, and then I don't want to play for a super long time. Alright, and then you can capture your frequencies and stuff. So if you made something like, I don't know if you make music or something, but you could sample this and get some really cool effects, I'm sure. But if you want to look at your waveform that you're generating, then you would just run this with Audacity recording, and then we can look at the frequency. And Audacity doesn't pick it up exactly because it's not going to generate like these waveforms right here. There's not going to be any level to that because it only has the options of being on or off. But yeah, so there's a couple things you can do.